रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मद कमा सल्लैता अला इब्राहीम व अला आलि इब्राहीम इन्नका हमीदुम मजीद। बिस्मिल्लाहिर्रहमानिर्रहीम। कुल हुवल्लाहु अहद अल्लाहुस समद लम यलिद व लम यूलद व लम यकुल लहू कुफुवन अहद। In this video, we will find the time it takes for a body to slide down an inclined plane from this point to this point, from this point to this point when it covers distance s. This example can be solved by using Newton's uniformly accelerated motion, the equations of Newton's uniformly accelerated equations of motion, but we will do it here in a different manner so that we can establish a method with which we can solve more challenging problems in life. Okay, so this phi is such that tan phi is greater than mu, the condition of sliding. Tan phi is greater than mu. Mu is 0.5 and tan phi is greater than mu. If tan phi is greater than mu, wherever we leave that box, it will start sliding down, won't stay there. Okay, so break up the forces as you know: mg cos phi, mg sin phi, mu, mg cos phi, force of friction. Okay, so when you release the block here, it will start going down. Why? Because let's say if there is no friction. If there is no friction, then the compelling force is this centripetal force, mg sin phi. So here is the Tahir center of rotation. It will be accelerated towards this center. When it is accelerated towards this center, as I told you in my previous video, we will solve all the secondary gravitation example with this. Okay. So since the motion is not sweeping out any plane, so these two couples can be considered oriented at any direction like this. Any direction, whichever you want. All four are equal to mv square over rho, where rho is the radius of curvature, which is infinite in this case. Because the body is going in a straight line, the curvature is 0. Okay, so when this mg sin phi replaces this mechanical force, centripetal force, replaces this, then this gets activated in the form of centrifugal force, Tahir centrifugal force, mdv over dt. These four are mv square over rho. This is mdv over dt. So mdv over dt gets activated in counteraction to mg sin phi, which is centripetal going in this direction, and this is centrifugal. You can watch my previous videos if you don't understand this. It's not that difficult. Okay, so the free body diagram is here of this block. Positive x is in this direction, positive y is in this direction. This is the origin. So body is going from a distance s towards the origin when released from here. Okay, force of friction, reaction, mg cos phi, mg sin phi, mdv over dt, the centrifugal force, centripetal force. Friction is an induced force, induced by the gravity components, but still a mechanical force. Okay, in Tahirian cosmology, systems are in extreme equilibrium even under extreme accelerations, as you know, as per Tahirian cosmology. Okay, so we get dv over dt is equal to, so we get this one, forces in the tangential direction is equal to 0, get this one, from here we get this one. Okay, so we break up it with chain rule by introducing the differential ds with the variable s, the distance traveled by the body in the direction of motion. Okay, so dv over ds over dt is g sin phi minus mu cos phi. So we get v dv is equal to g sin phi multiplied by ds. This is v. This ds will come here. So this will become v dv. So ds. Now this sin phi ds is minus dy. It's not dy. Similarly, this cos phi ds is minus dx. Why? Because when the body moves from here to here, or for example from here to here, then dx is positive and dy is also positive. But when the body is moving from here to here, then dy is negative and dx is also negative. So here is the turning point. No one has done it before in the last 500 years. So this is minus dv, this is minus dx. Here is the turning point, keep in mind. V square over 2 is equal to this, blah blah blah. v square is equal to this. So v is equal to 0. Let's suppose if we release the box here, then here the velocity will be 0. As soon as we release it, start going down, moving down. So velocity is 0 at x is equal to s cos phi. So s cos phi is this distance, and s sin phi is this distance. So we get c is equal to g sin phi minus mu cos phi times s. So v square becomes this. Okay, so time it takes from moving from here to here is integral of ds over v, because ds over dt is equal to velocity. So d is equal to ds over v, integrate ds over v. Okay, so integrate. Okay. Okay, so here's the game once again. Turning point. Minus dy minus dx. In the differential of the distance traveled is dx square plus dy square. You get this one. But here when you put minus dy over dx and take a minus dx out, this negative sign comes here. This negative sign comes here because the body is going like this and the dx is negative. So these two cancel out here, but here it stays minus. So you put here, you put the value of v from here. To this value you put v from here. Okay, now this, the bottom is this under the radical sign is a linear function. So you consider u is equal to this. This expression you consider equal to u. Then du is equal to this dx. Okay, so then you substitute the integration by substitution method. When you substitute, you get this one. Then when you integrate this, you get this one. Okay, now your limits is x is equal to s cos phi to 0. Okay, x is s cos phi. X is equal to s cos phi to body comes here when x becomes 0. X becomes 0. Okay, you put this one, blah, 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 you get t is equal to square root of 2 times s, the distance, divided by g sin phi minus mu cos phi. Or you can write it like this too. This is similar to Newton's uniformly accelerated motion. When the velocity is 0, for free fall or linear, half gt square, where g is replaced by this times this. T square half the same. Half at square, same formula. But we are doing it this way so that we can solve entire problems in the entire universe with this secondary gravitation. Newton's, unfortunately, highly unfortunately, Newton's uniformly accelerated motions, equations of motion, they are like the marriage of a rat with an elephant. Neither the rat can go into the elephant, nor the elephant can go into the rat. The marriage cannot be implemented and it cannot end up in reproduction. So totally useless, garbage. So t is equal to 2s g sin phi minus mu phi, blah, blah, blah. Okay, so when we put s, now we will, for the sake of extreme goodness, I will show in my next videos why I chose this point. I will take the x coordinates equal to 2 pi meters, approximately 6.2 something meters, and the y coordinate 4 meters. Why I am taking this? Because eventually I am going to find the time a body slides down a cycloid and a body rolls down a cycloid. Both times, we will calculate both times. We will develop the physics of, inshallah, I will develop the physics of sliding and rolling both differently, and we will find the times. Okay. Okay, so when you fit a cycloid, the cusp of the cycloid perfectly fits in this, with this ratio of this distance and this distance. So that we can compare all curves, infinite curves, with cycloid. Okay, so this distance is 2 pi meters and this is 4 meters. Where the radius of the generating rolling circle for the cycloid is 2 meters. 2 pi a, 4a, 2 meters. Okay. It's almost the same distance from there to there in this room. Okay. Okay, so when we put, so we release the body from here, 2 pi to 4, because eventually we are going to compare this time with the time of it takes on the cycloid when something slide on the cycloid. So here in this case, when something slides on an inclined straight line plane, equation y is equal to x tan phi, y is equal to mx, equation of a straight line passing from region O, 0. Okay, so gravity is the average gravity is 9.81 meter per second per second. Tan phi is equal to 4 divided by 2 phi. 4 divided by 2 pi. So not phi, 2 pi. The 2 over pi is equal to phi is equal to 32.48 degree. Mu is 0.5. When you plug in all these values in here, you get t is equal to 3.63 seconds. So if you slide, okay, let me clarify one thing. When you compare theoretical values with experimentation, then you have to perform the experiment with explicit conditions, clear, vivid conditions, ideal, perfect conditions, if you want to get this answer. Otherwise, you will never get the same answer. Okay? Your human error will keep on increasing and increasing and increasing. Okay, so the distance is very, the time taken is very reasonable. 3.63 seconds for a distance of 7.45 meter at an angle of 32.48 degree with a coefficient of friction 0.5. So the time is 3.63 seconds. I started from the simple. In my next video, I will use a curve, y is equal to ax square. Then I will derive the entire physics for that curve. In my next video, after that, I have done it, it's just a matter of writing down, making the video. And in the next video, I will use the cycloid. So I will compare 3 times of sliding. Then I will, for the first time in human history, Islamic history, I will develop the physics which could not be developed for the last 700 years. I will develop the physics for rolling, for circular cross sections. You got to listen to it very carefully. Rolling for circular cross sections. I will develop the physics for rolling for circular cross sections. And we will repeat 3 more videos on the time. Then we will compare all the 6 times together. Thanks for watching. Subhanallah walhamdulillah wa la ilaha illallah wallahu akbar wa la hawla wa la quwwata illa billahi al-aliyyil azim. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid.